Many sources of data have an underlying network structure. Think of a social network. A natural question to ask is, who is most influential? The answer to this question is not simply the person with the most followers. It's also determined by how influential the followers are. Another example is the World Wide Web. Everybody finds information on the World Wide Web by using a search engine. The most widely used is Google. In fact, it is so often used that to Google has become a verb. When you submit a query, Google returns a list of websites that it finds most relevant. In this part of the course, you will learn how this list is determined. It's a true big data problem. There are billions of websites and somehow Google orders this enormous amount of diffuse data into a selection of pages that are relevant to a query. The algorithm that does this is called the PageRank algorithm. It was developed by Larry Page and Sergey Brin in 1998. Both are co-founders of Google. Now, what is the PageRank? The PageRank of a page determines the relative importance of the page. To determine the PageRank, a model is assumed of how we find information in the World Wide Web. In this first video, we will introduce you into the ideas behind this model. In subsequent videos, we will explain the mathematical and computational details behind the model and also how to manipulate the model to get an artificially high PageRank. The PageRank of a page, or for short the PR, is a number that determines the relative importance of the page. Previous versions of the Google website even had a button that showed the PageRank number rounded to integers between 1 and 10. Of course, for companies it's important that the company website has a high PR. But for example, also for scientists it is important to have a high PageRank. It means visibility. Your peers will be able to find your reports and papers easily. By now, Google doesn't have the PageRank button anymore, because it stimulated people to manipulate their websites, such that the PageRank became artificially high. The PageRank is computed using a model for someone that serves the World Wide Web. It assumes that we can go from one page to another in two ways. We can follow the hyperlink, or, as we will call them, outlinks, or alternatively, we can jump from a website to another website. And this second way of going from one page to another page is called teleportation. That is, you type the address in the toolbar of a page that you want to jump to. By repeating these actions, so by either following a link or by teleporting to a page, both with a certain probability, we can compute the probability that we end up on a certain page. By surfing infinitely long, we get for every page a probability to end up on that page. If pages are well connected in the network, this probability will be relatively high. Pages at the edge of the network will get a low probability. This final distribution is the PageRank vector, and the individual probabilities are the PageRanks. Now, this is only an intuitive description of the PageRank. In the next video, we will derive a mathematical model for the web server that will allow us to compute the PageRanks.